Guys, welcome to another episode of Cuda Education. Today, just an intro video, really quick, nothing too serious. We are moving on to compute particles. So, this is the compute particles example. I don't know why it looks different when I moved it to the next screen. Let me see if I move it out and move it back in, if it looks different. I don't know. Maybe the displays are different. But we could see that it's basically, we have particles that are moving around, okay? And then we could attach a attractor to cursor, which basically, it basically repels the particles. Um, but yeah, I do notice though when you run it a couple times, right? Sometimes you get different colors, right? Um, so we're going to investigate this. This algorithm is actually a lot less compute intensive than the compute n body, and we'll get into that. We do two passes in compute n body. With this one, I don't think we don't do two passes, so the computation is a lot less intensive. I'm just running on the Intel GPU for now. I can't be bothered to switch over to the NVIDIA one. Um, but yeah, and then of course, if we mess around with the particle count, we get a different set of particles. Um, we get less particles, so we kind of have less particles here, and we still have our attractor thing here. If we just do one particle, we get, or one multiplication of the set, we just get this, right? And we still have our attractor, but it's a lot less stuff, right? Um, so we'll put that back. We're looking at 600 lines of code. So we'll do a quick random walkthrough. Update computer shader, attraction based compute shader particle system. Okay. So yeah, we'll just do a random walk down the algorithm. We also have three shaders. So we have a particle. Actually, let's just do that. We have a particle comp shader, computation, I believe this is. We have a particle fragment shader. We have a particle vertex shader. And then we have the source code here. All right, so let's just walk through the code quickly. Yeah, I know the timer. Remember we talked about delta timer and timing and things is very important in this algorithm. It shows up a lot. There is timing in a per second sense. So like a clock is per second, and then there's also timing in terms of per frame. So there's per frame based timing and per second based timing, or and we'll have to get into that. I don't I haven't fully investigated the story yet, but I know timing is a big deal in this one. We have a strut of textures, particle, and gradient.